Many thanks, Emmeline and Eric. Lovely to be here with you again. So let me start my slides. So biosecurity from space. Very pleased to be speaking on Yuri's night, and I'll be talking about various space-connected aspects, obviously enough. But a lot of the work which is involved here involves using space, if you like, as a platform to enable things down here on the surface of the Earth. And this talk is occasioned by the fact that we were very pleased at Xerra to have won a major biosecurity award, actually 3 awards. We won 2 separate awards just announced 3 weeks ago, and also we were the supreme winner of the New Zealand Biosecurity Awards. And as this announcement from the Ministry for Primary Industries says, biosecurity efforts have even expanded into space with Xerra Earth Observation Institute's leading edge software, which is helping protect Aotearoa from pests via international shipping. It's important bit on the end there, the via international shipping. There have been various media stories and ongoing interest in this platform, which we've developed, which we call Starboard. And some of the media initially thinking, well, you're protecting us from bugs coming from space. Let me assure you that that's not the case. I have great interest in whether there's life elsewhere in the universe. We certainly know of none, so we know we're not trying to protect ourselves against bugs from space. It's trying to protect New Zealand from various types of bugs which could be entering our ports on various ships, on various sailing yachts and so on. And also the platform, I should emphasize, although it's being developed here in New Zealand and the first applicability is to New Zealand, in fact, it's of global applicability, and we're certainly talking to and contracting with clients spread around the globe. So it really is a world leader in terms of what we do. It's very much a team effort. It's just me speaking here tonight. It happens that we're just having our team days, which we tend to have every 4 months. We're in the Wairarapa near Martinborough. There's the team. You can see we're not a team wearing suits and ties or any of that sort of thing. A lot of software engineers, a lot of marketing people, and a group of 5, 6, 7 of us who have scientific backgrounds, all working together to produce one coherent whole. As I said to Emmeline and Eric before the start, I'm actually missing the team dinner at the moment, but I'll be popping off there when we're finished at about 8 o'clock. But please don't let that stop you from asking any questions. I'm really pleased to stay around and address questions, or if you want to get in contact with us, please do so via all sorts of ways on the web and so on. We're easy enough to find. So that's the team. Current government and fisheries customers, just to say, yes, there are 4 government departments here from New Zealand: Ministry of Transport, Department of Conservation, the New Zealand Customs Service, and the Ministry for Primary Industries. We're currently sponsored largely by the Ministry of Business and so on, MB. However, we do have overseas clients. We're working with the Pacific Islands Foreign Fisheries Agency. We're working with Australian Government Department, the Australian Fisheries Management Authority, and we're certainly expanding into those 2 areas, that is Pacific-wide and also Australia. But again, we are talking to people and governments and government agencies and charitable foundations and so on spread around the globe. So this is very much something which is at an early stage of development, but we've got, as I say, already a world-leading product, and it's becoming more and more prominent as time goes by. So let me show you, first of all, just a few examples of what I'm actually talking about. So here's a slide: understand the maritime world in real time. On the right, the 2 different depictions of this platform, which we call Starboard. It can have a web interface, so you can be looking at it on a laptop. Equally well, let's say you're working for Customs, New Zealand Customs. You might want to be able to look things up on your cell phone, and so there's a cell phone representation there. This is very much a portable, displayable on almost any sort of modern device platform, and it just shows one particular fishing vessel. It happens there. I'll be talking more about what the various symbols, colors, and so on actually mean in terms of the processing of data within Starboard and our data sources, which, as I say, are almost entirely coming from satellites in orbit. So Starboard, what is it? It's a secure and intuitive web-based maritime domain awareness platform, maritime domain awareness, MDA. It combines the global automatic identification system for vessels, that's AIS, multiple layers of satellite data I'll talk about in a little while, various scientific models and other intelligence to understand the maritime world. So it's used by customers which have to tackle complex challenges ranging from the risk assessing arriving vessels. So do they have COVID on board? Do they have various types of insect pests and so on, through to detecting illegal fishing and also in covering non-reporting type vessels. Now, all vessels above 300 tons or passenger vessels are by international agreements supposed to have an AIS system transmitting. However, some don't, they turn them off for various reasons. And we have ways of detecting those in using other satellite systems. Okay, just an animation here to show you a few vessels. This is just over about 10 days. And the idea here is just to show that, yes, we can see vessels, we can track them. There's different colored symbols for each of these vessels. There's a large number of them there, which are shown with red symbols. Those are ones which the Starboard platform has assessed as being risky. Risky largely for two different types of bug, brown marmorated stink bug, and also a type of moth, which has been called Asian gypsy moth. It's just been decided internationally in the last couple of weeks that that's an offensive name, and so it's going to be called the spongy moth from now on. So we'll need to change the way in which we represent it. But if a vessel is in port in various different countries at different times of year, it's possible that it can pick up one of those pests. And then if it's coming, let's say we're interested in New Zealand, the authorities need to know what the risk is. So which vessel is risky and which is not. So the red symbol shows ones which are risky for this particular time frame. When there's a white symbol, it's our denotation that it's unknown. For some reason, perhaps they've switched off their AIS at some stage for 12 or 24 hours. We would then flag it as being unknown. We can't say whether it's a non-risky vessel or not. And the dark blue symbols are vessels which are judged to be non-risky. They haven't gone to any of the risky ports, or they've been inspected by, let's say, quarantine services here in New Zealand and been cleared. So that's the sort of thing which we can do. That was easy enough when we look at just a few vessels, which we had in that last depiction. But here's a map which shows on the Starboard platform the tracks by vessels over just 1 week, just a couple of weeks ago, March 22nd to 29th. And as you can see, it really is a ball of string. And the problem is, which of those lines are vessels which are significant for whichever country you're interested in, or whichever fishing area you're interested in. You can see there are many different vessels which are clearly cargo vessels going long distances across the north of the Pacific. You can see they're following curved lines. That's because they will generally be following the shortest route, which is going to be an arc of a great circle. And you can see very, very greatly congested areas. You can also see we've got AIS signals from vessels going up major rivers, like, for example, the Yangtze, the Amazon over here, the Mississippi and Missouri system over here, into the Great Lakes in Canada and the US. So there's all sorts of places in which people are tracking vessels or needing to track vessels. And that's what we're able to do using Starboard. We receive about 35 million locations of vessels a day from the automatic identification system. Another thing you can see, apart from the obvious cargo vessels going long distances, you can see various squiggly lines across the Pacific or across here in the Indian Ocean. Those are almost all fishing vessels. So they're following very different tracks, and we have different ways of looking at those, investigating them, looking at which vessels are coming to meet them. So, for example, tanker vessels may be bringing them more diesel or more water. There may be reefer vessels which are picking up fish from them and so on. And so those are fishing vessels, and certainly the tracking of fishing vessels is a major part of what we do with Starboard. Now, let's just zoom in a little bit to the Western Pacific and New Zealand, Australia, and East Coast. You can see it looks very, very congested, very, very noisy. We see various tracks, which are the way in which vessels are going, but you can also see lots of white dots. which appear to be isolated. Those are what we call ghost vessels. Those are actually AIS positions which are either been erroneously reported by a vessel, or sometimes they're deliberately spoofing. They're not saying where they actually are. They're trying to fool people into thinking they're somewhere else. So quite a prominent example in the media a couple of years ago was a fleet of fishing vessels which were actually off the coast, the west coast of South America, but were reported as being relatively close to New Zealand because they were spoofing their AIS positions, which again is against international agreements and so on. But if we take a look at that, we can see it's really rather problematical. How do you make sense of that huge complex? First of all, you need to weed out the ghost ship reports, but how do you make sense of everything else? If your particular interest is, let's say, knowing which vessels are coming into a New Zealand port sometime in the next few days, and perhaps they're judged to be risky because they've been to a port previously in which they could have picked up one of these insect pests. So how can we make sense out of this? Well, this is what we do with Starboard. We try to make sense out of a very complicated situation. As I say, 35 million AIS positions per day. So what we do is we have an automated system for analyzing tracks. So we analyze key events. So what's a key event? Well, it could be when two vessels meet at sea. They're both transmitting on AIS. We find that they have, in essence, a very, very close proximity to each other, maybe within a couple of 100 meters for 15 minutes. We would count that as being an encounter. We can automatically identify fishing activity. We can identify port visits or coming into an anchorage outside of a port. We can see when vessels are loitering, that is going slowly. They might be doing that not for any surreptitious purposes, but they might be doing something like cleaning out the ballast tanks. And there are rules which apply to that as to where you can do that. So there's all sorts of AIS data issues which are automatically detected, they're flagged, and they're stored to create, as we say, a rich data set describing the maritime world. So here is actually a fictitious example of a fishing vessel. If we stop at the bottom, it's a white line coming up. That's a normal, straightforward travel. But then we identify another vessel has come in and met with it. So we flag that and we color with that symbol, going in 2 arrows. That's a possible transfer between vessels. So for example, if we saw two vessels meeting in the middle of the Pacific and then heading off in different directions, we might think that's perhaps a little bit suspicious. There could have been something like a transfer of drugs, so drugs being brought perhaps from South America to New Zealand or Australia. So that could be of interest. All sorts of different reasons we would perhaps be interested in encounters. And loitering, which just means it's going at speed below 2 knots. If we find that the AIS has been switched off and so there's missing AIS data, we make the track a dashed line. Here, we've got a vessel going north-south in this kind of up and down pattern. That's very characteristic of fishing behavior. Sometimes it's east-west, sometimes it's some other angle, but the way in which ships, fishing vessels move and the speed with which they move and how they turn around and head in the opposite direction, maybe to pick up a set of buoys, which they put out with long line fishing rigs on. We can identify all those things. Just to mention that one of our things we see a lot of, an awful lot of buoys, which also have AIS transmitters on board. That's the way the vessels find the buoys again. So that's something, again, which we will automatically identify. We will identify when a vessel has dropped a buoy overboard and then when it's picked it up again later. Carrying on the track, we've got here something flagged as being an area alert. What that means is it's crossed some sort of legal boundary. In this particular case, it's crossed the 12 nautical mile territorial waters boundary around the 3 Kings Islands, which are part of New Zealand territory. And so we can have an automated alert. And in fact, we set up these alerts so that you get an email, perhaps once an hour, perhaps once a day, depending upon your needs, to tell you when different vessels have done different things. So approaching New Zealand, coming within our exclusive economic zone, that's the sort of thing which we can automate in Starboard and send out alerts to our clients. So there's one example. Here's another example of sort of complex analysis that can be done. So here we've got a vessel which is calling in I think this is the Bismarck Archipelago, part of Papua New Guinea. What we've said in Starboard is show us when the vessel has had encounters and it's also has data gaps, and also it shows fishing behavior, and also it's entered the exclusive economic zone from a foreign port. So that's selected out that one vessel out of perhaps hundreds or even thousands of vessels in that region. And we see there's two boundary crossings. Here it's come into the exclusive economic zone of Papua New Guinea. Down here it's crossed into the exclusive economic zone, which is 200 nautical miles of the Solomon Islands. And here we see the pink coloration that's an automatic identification of fishing behavior. And here we see it's had an encounter. So maybe it's transferred its catch to another vessel, which is going to take it back to its home port. That's the sort of thing which can be done in Starboard. Again, as I've already said, you can monitor areas of interest. So here we've thrown the 200 nautical mile exclusive economic zone around Australia. And here we're saying, well, which vessels have entered that exclusive economic zone from a foreign port? And that's being done automatically. So the area we've clicked here is the Australia EEZ, and the vessels, we said, all the vessels, please highlight the ones which have entered the area from a foreign port and hide all the rest, because it's just noise, all the rest. The Australian authorities might need to know that specific thing, which vessels are doing this over a certain length of time. This was just a couple of weeks ago, from the middle of March, 2 days through the 17th of March, and on we go. We can also, as I've said, identify risks before the vessel reaches the border, and that's going to be very useful for customs and quarantine and so on. So here is a vessel, it's the Condor Patagonia. In this red symbol here, it says AG, that's Argentina, so that's where the vessel is flagged. And its track history here shows that it was in a Spanish port. It could have picked up brown marmorated stink bug, and so it's then highlighted in red, and then we show the next port which it's coming to, which is a port in Colombia. So that can identify things like the biosecurity risks, and also over the last couple of years, we've been looking at the likelihood of the crew having COVID-19. That's something which, of course, we will be phasing out now, given that there's now so much air traffic. The worry about vessels at sea bringing in COVID-19 is no longer quite as much of a concern. Still of a concern, obviously, to various Pacific Island nations, but not, say, to New Zealand and Australia. So people online here are interested in space, so let me tell you about the space component. So we've got a worldwide identification tracking of vessels. What do we use? We use the AIS system, largely received by orbiting satellite constellations. I'll say a little bit more about that in just a couple of minutes. We've also got satellite-based geolocation and navigational radars. In essence, every vessel at sea has a navigational radar, whether it's a yacht or an ocean-going liner. They can have multiple navigational radars on board. It's now possible, in fact, to map those from orbit using different dedicated satellites, and so we can geolocate them. We can say where they are. We can also determine what sort of radar they're running, and that allows us a certain amount of, you could call it fingerprinting. We can also do synthetic aperture radar from orbit. That means you're actually collecting an image, if you like, of an oceanic area. And from that, we can detect vessels which may have their AIS switched off. We can also use optical satellite imagery, which is the obvious way of doing things. However, it does have limited utility in what I'm talking about here, due to the fact that optical satellites cover relatively small areas. So let's take a look at what we do. Currently with Starboard, we're using a data feed from a company in Canada called Exact Earth. SAIS, it says here, that means satellite AIS. Originally, the automatic identification system was set up with only terrestrial receivers, that is radio receivers spread around the coasts of the world. And then those can only receive AIS signals when the vessel is within essentially line of sight. So maybe out to a few tens of kilometers from the shore, because the original purpose of the AIS system was to be able to enable vessels to see if there are other vessels nearby by having a map as such of vessels using the AIS locations, which again are determined using GPS receivers. That since has been expanded, and there are various companies which have constellations of satellites which are able to pick up the AIS signals no matter where the ship is in the world's oceans. So Exact Earth actually has a set of AIS receivers on a total of 58 of the Iridium NEXT constellation, 58 out of the 75 in orbit, also 10 other satellites which have exact Earth receivers on board. Exact Earth has recently, towards the end of last year, been taken over by another company called Spire. Spire has its own constellation of satellites, and so with the two added together, there's going to be a much bigger and more complete record of AIS signals. So that's one way in which we use space. Another way we can use space, obviously, I mentioned previously, is optical satellites. Just to show you the constellation of satellites, which is operated by the company Planet. It's a small company based in San Francisco. They have about 200 satellites on orbit. One of their marketing boasts is that they image the whole of the land area of the Earth every day with a resolution of about 3 meters. So that's the size of pixels, about the size of a large car, I guess. And more or less they do that. There are some areas which obviously for one reason or another may not be covered on a particular day. And also there's problems with cloud cover. Now, you might think this is the best way to scan the oceans, but actually it isn't. Reason being that the imagery is a relatively small area. Typically, the Planet images are about 20 kilometers across. Even if you've got 200 satellites collecting imagery, you can't have continuous coverage of all of the oceans. So we're not up to that stage, as it were, yet with optical satellites, and also that's a problem, as I say, with cloud cover. We get around that in a different way. So the way in which we get around it is using different types of satellites. So let me just, this is just an imaginary operation. Imagine that we're wanting to scan an area of the ocean to the southeast of New Zealand, to the southeast of the Chatham Islands. The white square I've shown there, that's our fictitious area of interest. And we imagine that we're wanting to patrol that to see who is fishing there, are they fishing legally, is everything above board, and so on. So it's a fictitious area I've chosen. It's not in anybody's exclusive economic zone. So it's just an imaginary exercise, if you like, for me to show you what sort of things we can do. Now, first of all, I've got a constellation of AIS receiving satellites there, which are very similar to those for exact Earth. And the footprint for each of those is shown by these circles underneath the satellites. And I've shown actually 4 in this view. You can see it's like a huge cone going up to the satellite. Now, the AIS transmitters on the vessels actually are transmitting their signals close to the horizontal. That's the way in which AIS was originally set up. It was set up to be received by receivers on land and not by satellites which are overhead. And so most of the signals, most of the AIS signals are actually picked up when the vessel is close to the edge of these circles, not directly underneath the satellite, because the satellite, because the vessel isn't transmitting a radio signal straight upwards. So with that in mind, you can see that although we may get coverage of most of the Earth's oceans, there are going to be times when there are gaps between these coverages, but generally they're only a few minutes because these satellites are in orbits which take 90 to 100 minutes to orbit the Earth. And we've got pretty good coverage when we've got a matter of maybe 100 satellites in a constellation picking up these signals. That's great. That gives us the AIS signals if the vessel is transmitting, but we are interested in vessels which are not transmitting, which we call dark vessels. So ones which may be doing something a little bit surreptitious. How can we detect those? Well, first of all, we can task a synthetic aperture radar satellite. The one we use a great deal is called RadarSat-2. It's run by a Canadian company, and it can cover a certain area as shown by the yellow kind of square there. That's the amount it can collect in one coverage. The coverages last for about 66 seconds. They cover 225,000 square kilometers. And we have ways of then searching that image, the SAR image, automatically and identifying vessels. A limitation, however, is that generally you can only detect metallic vessels. So it's not of any use for detecting smaller wooden fishing vessels. And that's a problem. On the other hand, almost all vessels, as I've said, have navigational radars on board. They're kind of essential for safety and also seeing where other vessels are if you're in a fleet of fishing vessels. We can pick those up using a different sort of satellite we call RF detecting satellites. So RF is radio frequency. So those will pick up the satellites, pick up the vessels from their navigational radars. And I've shown 2 here. I've labeled B4 and B5. There are actually 3 companies in the world now which have satellites which do this. We've been working with a French company called Unseen Labs, and that's that gives these names. These are called Bro4 and Bro5, two of their satellites. They've just launched another two in the last couple of weeks. So they had a launch in January. So they're now up to 7 satellites in orbit. There's an American company called Hawkeye 360 we're also working with, and a company based in Luxembourg called Plios, which is launching a constellation of satellites which will be able to do the same thing. So this is a way of mapping the vessels at sea using the navigational radars. Just zooming in a little bit to show you what I'm talking about in terms of the geometry. The R2 satellite, RadarSat-2, its beam points out sideways. There's essentially almost no control over that. So we get rather infrequent opportunities to cover any particular area. As time goes by, there are going to be more and more radar satellites in orbit, like RadarSat-2. There are two commercial companies, one in Finland called ISI and one in the US called Propeller. They're both aiming to launch about 3 dozen radar, synthetic-aperture radar satellites into orbit, and then we'll be able to get more frequent coverage. B4 and B5, these RF satellites, they again need to look sideways from the satellite. The reason they need to do that is, of course, the navigational radars on the vessels are pumping out their radar energy sideways, and so these satellites need to look towards, as it were, the limb of the Earth as they look down. The reason that these coverage patterns look the way they do, a kind of elongated trapezoid with a curve on one end, is to do with the fact that the Earth is curved. And so in fact, the coverage of these, if they were pointing straight down, they would be squares underneath the satellite, but they're not. They're looking out sideways and covering a larger area out towards, as I say, the limb or the horizon as seen from the satellite. And they can map whichever vessels have navigational radars within those footprints. They scan for about 10 seconds. They then analyze the data and give us a set of positions for the satellites. For the vessels, sorry. Now, what does RadarSat-2 do? Well, it does this sort of thing. Over 66 seconds, it covers an area of about 225,000 square kilometers. The data will typically be downloaded within about an hour down to a ground station. We then get the data from the company in Canada, and we do an automated search to pick out the vessels which have been detected. The reason I've got it there across the Tasman Sea between Australia and New Zealand is we're currently planning another operation, which I'll say a little bit more about in a few minutes. Okay, moving along. What do I mean by picking up dark vessels? So here we've got the far north of New Zealand. So when a vessel, which we call it dark, is when it's got its AIS switched off. If it's got its AIS on and we detect it in a SAR image, then we would show it as being white. So these three here, those are vessels which have been detected in an AIS image. And this black and white image you can see there is actually a SAR image, synthetic aperture radar image from a European satellite called Sentinel-1A. And what we do is we find the vessels in the image and then we try to match them automatically against known AIS locations. If they match, then they're not dark and we represent them with a white symbol. If, however, they are not on AIS, then we would represent them with a red symbol. So here, as I say, is the SAR satellite image. Elongated, expanded here on the right is the sort of panel which will come up in Starboard, which shows you, first of all, a zoom in on the particular part of the image. So these two blobs here are the vessel. And you could say, why are there two blobs if there's only one vessel? And the answer is this looks like it's a cargo ship. It's got a superstructure on the rear of the ship and a superstructure on the front of the ship, which is giving a stronger radar echo. And so that's what the image actually looks like. The size of the pixels in this case are something like 10 meters. They can be as small as large as 20 meters. That's a typical resolution from a SAR satellite. So we can see bigger vessels. We can't see smaller vessels. We can't, so a yacht wouldn't show up almost certainly, and also wooden fishing vessels won't show up. But all substantial size metallic vessels are fairly straightforward to pick up in SAR imagery. So underneath, we've got some information. We say the latitude and longitude. The detection was automatic. It's an automatic search of the imagery, manually verified, perhaps I should say visually verified. That is, we've actually taken a look and say, yes, that makes sense. We've got high confidence that that is indeed a vessel in that location. It's got its automatic identification switched off for one reason or another. That's using SAR imagery. We can also use, as I say, RF detections. And here we've got a vessel which has been picked up from its navigational radar. Whoops, sorry. And we have detected it with one of these satellites. We pick up the RF signals. We can say it's latitude, longitude. We know it's an X-band radar. We know its operating frequency. We know its PRF, its pulse repetition frequency, how many pulses a second it's pumping out, and also the duration of each pulse in microseconds. That allows us a certain amount of fingerprinting of particular radars on particular vessels. Okay, I've shown this picture before and said, the problem is, how do we see what's going on in this chaos? Well, up at the top in this red box, we're showing everything as shown in map, means the whole of this area and all vessels on the map. So we're seeing an awful lot of chaos, and we want to be able to sort out the signal, if you like. How do we do that? Well, we can change the area to say New Zealand's exclusive economic zone, and we can show just the vessels which have entered that area from overseas. And those vessels we described here down on the left, most of them are shown here as white dots, and those white dots mean that they are no problem, either from the COVID-19 risk or the hitchhiker pest risk. However, there are a few which show as red dots. For example, this one here, that one clearly has a high risk assessed, and we would be able to zoom in on it, click on it, and it would tell us why it's assessed as being a risky vessel. So this is risk to New Zealand from vessels arriving from overseas. You could equally well do the same thing for, say, the Australian EEZ or the Philippines EEZ or any other nations. And we're gradually adding different exclusive economic zones so that different clients in different countries can do exactly the same sort of sorting. Another thing we can see up here in this yellow box, there's some sort of vessel, and unlike the straight, more or less straight lines which cargo vessels show, this one seems to be zigzagging a bit. So let's zoom in on it. Well, the reason it's zigzagging a bit, it's a sailing vessel from Belgium. It turns out it's called Adventure. It's come through the Kermadecks. It's zigzagged around a little bit. Now, the important thing is that this was in July last year, still when we were very concerned about vessels coming into New Zealand, potentially carrying COVID with them. Our automated extrapolation of its speed and direction shows that we expect it to arrive in New Zealand at Papua about 4 days after it's been detected here. So that gives customs and quarantine and so on some advance warning that this vessel appears to be coming to New Zealand. It's already in our exclusive economic zone. It also tells us how long it would have been at sea at that time. So almost 20 days, so it wouldn't have been a very high COVID risk. And also we can backtrack and see where has that vessel been in the past. So could it be bringing any of the insect pests to New Zealand? How else can we find vessels at sea which may be trying to sneak in? Well, we can look at areas which are suspect areas, and the Minerva Reefs is a good example. Minerva Reefs are basically a yachting crossroads between Fiji and New Zealand. Awful lot of vessels coming from either French Polynesia or Fiji or New Caledonia will put in at the Minerva Reefs just to have, I guess, a bit of calm water for a little while and meet maybe friends with other yachts. And there's two tracks shown here coming in to North Minerva Reef and then departing again. We can zoom in and see what the names of those vessels were. This was in actually end of July, beginning of August of 2020. So two vessels there. We tracked on AIS, and they're reporting. A lot of yachts do have AIS just because they want their friends and family to know where they are. However, we can also get optical imagery. As I said earlier, optical imagery can only cover a relatively small area. Each of these reefs are only about 5 or 6 kilometers across. So here's a planet image of North Minerva Reef. That's a nice clear day. This is probably more typical, close to the equator, kind of cloudy, but nevertheless, a lot of that reef is still available for us to see. And the sort of thing we can see at different times is something like this. So this was back in 2019, before the COVID era. And very often in these images, we would see even a dozen yachts which are put into the North Minerva Reefs. They spend a day or two there and then on they go. So these images are 3-meter pixels. So you can actually make out that these dots are indeed yachts. For example, this one here at the top left, we can see the white reflection of the vessel itself. We can also see its shadow on the sea bottom. The water is very shallow here and varies with the tide. We can also see that different vessels have different colors. So this one's a kind of pinkish color. Who knows why? But anyway, there are ways of picking these things up. The point is that using optical imagery, the ocean is a vast place. But if you're interested in certain crossroads, you can, as it were, zoom in and get useful optical imagery. Let's talk now about fishing vessels. Obviously, it's important for us to know within New Zealand's exclusive economic zone whether the vessels which are fishing are either New Zealand registered, so they're allowed, or they are licensed to New Zealand. We also need to monitor our marine reserves and make sure that vessels are not going places they're not supposed to. So here's a single shot over about 10 days across the subantarctic islands, the Auckland Islands in particular. If we zoom in, we can see various vessels are here. They've been fishing. They're outside the 12 nautical mile territorial waters, so that's fine. Just one we've highlighted here, fishing vessel Ocean Pioneer. So its track is shown in a more bold white and then pink when it's fishing. You can see it's twice come in close to the Auckland Islands, and that's legal, that's allowed. The reason is the weather's turned bad. So this is across the middle of July, so it's the middle of the winter, and in the subantarctic islands. It's done tracks backwards and forwards off the east coast of the Auckland Islands just to keep in the lee of those because there was a storm coming from the west. And then another time it's actually put into this cove here. Again, they're allowed to do that. All diesel vessels, however, have got to stay at least 1 kilometer offshore. So again, that's the sort of thing we can check on using the AIS. And I emphasize that one of our clients, Department of Conservation, are interested in this sort of thing. But a lot of our fishing patrols is actually for, how can I put it, vessels from other countries, maybe illegally fishing elsewhere in the Pacific. Just out of interest, I show this shot, a little bit of brinksmanship here. This is from March of last year, March of 2021. This is the Bering Strait between Alaska and Siberia. And you can see this line diagonally coming down through is the junction of the two exclusive economic zones. And you can show the Russian fishing fleet. You can see the Russian fishing fleet over here and the US fishing fleet. Real bit of brinksmanship. In fact, there's even evidence maybe just there that one of the American fishing vessels has gone over that line, but they are really fishing right the way up to that boundary between the two. Okay, one thing which we have done in 2020, and we're aiming to do again in a few weeks' time, is searching for dark vessels which are fishing for southern bluefin tuna in the Tasman Sea. That's an endangered, has been an endangered fish. The stocks are now growing again because there is international agreement between New Zealand, Australia, Japan, and various other countries in terms of what fishing can be done and limitations on what can be done. So these areas here where you see pink, that's identified fishing behavior from the AIS signals. We can zoom in and you can see in more detail, fishing vessels are going backwards, east-west, fishing for tuna, here east-west again, there's some going north-south. Whoops, sorry. And we've got a synthetic aperture radar image collected using the radar Sat-2 satellite. We will identify the vessels which are there. We will identify whether they are indeed on AIS. And if they are not on AIS, we have a red symbol. If they are on AIS, then we have a white symbol. So that's what we can do using synthetic aperture radar. We can also map that area using RF emission, so picking up their navigational radars. This is from May in 2020 when we were running a Tasman Sea operation. The coverage area we've represented here by this ellipse. The white squares are vessels with navigational radars detected, which we are matching against their AIS positions. However, the red symbols are ones which are, we're picking up their radars, but they are not transmitting on AIS. That is, they've gone dark. So the white 5-kilometer circles are matches against the automatic identification system. We do that automatically every day in Starboard. The red symbols, as I say, are vessels for which we're picking up their navigational radars, but they've switched off their AIS, which they're not supposed to. So we can see here, there's a whole red, in red, there's a whole dark fishing fleet, which we've detected. A useful result. As a consequence of that, the sort of thing which would happen would be either Australia or New Zealand would send out surveillance aircraft like a P3 Orion from New Zealand, Royal New Zealand Air Force, and try and photograph these vessels once we've told them where they are, so catching evidence of them actually fishing illegally. We're running another operation like this, another Tasman Sea operation, in collaboration with the RadarSat-2 company in Canada. That company is called MDA, and also Unseen Labs, the French company which do RF detections. That's part of the Indo-Pacific Expo, which is being run in Sydney from the 10th to the 12th of May. We're actually running prior to that another operation elsewhere in the Pacific. I can't say where because that's not exactly secret, but it's confidential information with that particular Pacific Island nation. And so this is the sort of thing which we're doing in essence all the time. So I've tried to show you some of what we do and how we do it and how space is involved in this whole thing. So what does Starboard do? It enables people, enables countries to monitor their national waters and help protect the world's oceans. We're interested in doing good things, environmental things, and stopping illegal fishing. But also there's the biosecurity aspects, which are to do with unwanted pests coming into New Zealand or other nations. And again, continuing in terms of protecting various Pacific Island nations against COVID penetrating. So I'd be very happy to answer any questions. I see there's been various things put up on chat, and we'll move over to that now.
Thanks so much, Duncan. Yeah, what a really powerful software tool as well, and just the impact that it could do to kind of like the global fishing and biosecurity kind of like around the world. So yeah, we have a few questions on chat.
Do you want to allow video and
yeah, I'm going to do that, but one.
Okay. Yeah, there are a couple. Let's see. Penny was asking. First off, yeah, at present, is biosecurity risk only defined by port visits? Is there a chance that shipping companies can also have risk data from the shipping contain? There's I guess there's a treatment of fogging treatment in Pacific ports.
Yeah, and the answer to the questions, very good questions, is yes and yes. Currently, it's port visits or anchorage visits. The thing we're looking to expand now is actually biofouling. That is when the fouling on the underside of vessels. So charting where a vessel has been in the past in terms of which waters it's been in and the temperature of those waters, and therefore what sort of encrustations you might expect on the bottom of the vessel. And so that's to inform mostly New Zealand authorities currently, but it could be, of course, other nations, Australia, Philippines, elsewhere, to say, whether a vessel needs to be cleaned before it's allowed into port. And again, it's all a matter of, it's such a problem. There's so many vessels, there are 500,000 vessels globally. How do you choose the ones which you inspect or are the highest risk? And that's, I guess, the name of the game for us. Aiding the biosecurity authorities to identify the highest risk vessels, given that you can't search every single vessel. And it's also, this is kind of an intelligence service, if you like. That is, vessels may be not correctly reporting or not completely reporting. So that's the sort of thing. The next question was about toothfish, Patagonian toothfish. The answer is absolutely yes. It's a great question. And we looked at doing this about a year ago. We found there were so few vessels down there that it wasn't a useful thing for us to do at that stage of the development of Starboard. It doesn't mean to say we won't do so in the future, but if you like, we needed a good signal noise ratio. We needed a good number of vessels to be processing to try identifying things. And when we took a look at what was happening down there, there was very small numbers of vessels. It was like 4 or 5 or 6 at any particular time. So would we, for example, task synthetic aperture radar image or the RF satellites? The answer has to be no, because it's pretty costly to get that done. As you can imagine, it's thousands and thousands of dollars every time. And so in terms of developing our methodologies for doing things, we thought, hey, we'd love to be doing it, but we had to look at other areas initially. But again, it's a great question, and certainly something which we very much hope to be getting back to in the future. And of course, we always in that sort of thing, we hope we find nothing. That is, we hope we don't find anybody illegally fishing. But I guess part of the game is, if they know that we could see them, it really is a discouragement. That is, the police don't put out speeding cameras in the hope of catching lots of people speeding. They put out speeding cameras to discourage people from speeding. And so this is a new, if you like, intelligence layer or way of gathering information, which we hope will discourage illegal things. Okay, how does all this monitoring fit with emergency beacons and personal locator beacons? That's again a great question. I won't go back to my PowerPoint presentation, but when I showed the satellite constellation for picking up AIS, it showed a vessel track going down to the Antarctic Ocean, and I forgot to say anything about it. That was actually a vessel out of Wellington, operated by NIWA, the National Institute for Water and Atmospheric Research. It had AIS transmitters on board, and at different times was transmitting different types of AIS signals. And so we were doing an experiment in terms of, if you like, tracking them. They also threw aboard, if you like, life raft with emergency beacon and personal locator beacons on board, and they knew exactly where it was. It was relatively close by the vessel, and so we could see whether we could see it as well. And the answer is yes. So we've done testing on that. Again, it's something which we would very much hope to expand into in the future. There's so many things we could do. Starboard is a fantastic tool. I shouldn't say it's absolutely unlimited, but there are an awful lot of things which could be done. Next question I'm reading out here. You said that AIS is mandatory for vessels larger than 300 tons. How do you know which vessels are above 300 tons and therefore dark or suspicious? Again, great question. An AIS message doesn't just show the latitude and longitude. There's a whole lot of other metadata in there. The name of the vessel, there's different identifier numbers. One's called a MIMSI. I can never remember what MIMSI means. One is called the IMO, which is the International Maritime Organization identifier number. There's also its call sign, its radio call sign, which is generally a string of 5 alphanumeric characters, but can be different. So there's lots and lots of different information, including its weight, its draft, its length, its width, and so on. So there's a lot of other things which are in there. So one of the big problems we have is, of course, as you can imagine, if there are 500,000 vessels, a lot of them have actually got the wrong information in there for one reason or another. It may not be deliberate, but vessels get reflagged every so often, and they get sold. And do they update their AIS messages? Not always. So it's a continual problem for us, and we're looking at ways to expand our checking, if you like, on that information. I can't say too much about it, but we're certainly working with, let's say, some big international companies who have interests in this, and we will be able then to verify and check the accuracy of the information we're getting. Okay, I'm curious about where to obtain AIS data. Is it available for everyone? Well, if you've got a receiver, you can go up to Port of Auckland, for example, and receive the AIS data, which are coming from the vessels as they come in. But globally, especially buying them from these different networks like Exact Earth and Spire, it's pretty expensive. So different companies here in New Zealand run terrestrial receivers, and like I say, globally, there's networks of terrestrial receivers, and there's several companies now which have satellite constellations. And as you can imagine, they need to make money, and so they need to charge, and that's a major expense for us. But we're exploiting that data progressively for all it's worth. Marine traffic, as one of the apps that provide AIS data, that's entirely correct. As it says there, everyone has limited access. And again, go take a look, see what marine traffic do. There's several other companies which do these sorts of things, and it's very illuminating to go take a look. Shipping container risk is another significant biosecurity thing. Yes, again, this is a great question, because we have looked at this, because As one can imagine, with more and more smart containers, as it were, it won't be a matter just of tracking vessels. It will also be tracking the containers which are on board. So individual containers, take into account that some of these very big vessels, like the one which ran aground in the Suez Canal, they can have 20,000 vessels of containers on board. So if all of those are all transmitting AIS signals, you get into a problem of, we call it collisions between AIS signals, which to a physicist it doesn't sound right that I'm a physicist, but it tells you what it is. You know, your receivers can only handle so much incoming data at any particular time. So that's collisions. But yes, you know, the granularity is becoming better and better. And this certainly will be the way of the future, that individual containers will be tracked. Do you think the likes of Starlink will have a bearing on maritime intelligence? Absolutely. In lots of different ways, which we can imagine, and also ways in which we can't imagine yet. But I mean, clearly, you know, every cruise liner now, everybody's going to be expecting to have streaming Netflix and Apple Plus TV and everything else because of Starlink. So, you know, internet will be absolutely everywhere. There is a company called O3B, and that was called that because that's other 3 billion was the idea, to give the internet to the other 3 billion people in the world who don't have the local infrastructure required. But who knows what's going to happen in the future. I have a particular interest in Starlink for various different reasons. And one of my little movies, which I show in some talks, shows the Starlink satellite constellation. When it was at about 2,000 satellites, it's up to something like 2,500 now. It's quite astonishing. And of course, the idea is for 42,000, and there are other constellations. Unfortunately, that's a problem for ground-based astronomers, but that's a different talk. Thanks very much to Anthony for your thanks. Appreciate it. I love giving talks like this. I love talking to people who are enthusiastic like me. And Eric and Emmeline do a fantastic job in getting out to the space community and other communities, going out to schools and everything else. It's just great. And as it is happening here in New Zealand, we're a distributed company. So although our base our headquarters is actually down in Alexandria in Central Otago, we're spread all over the country. I live in Nelson. Another software engineer happens to live in Nelson, but we're spread all over the place, and we use Zoom, and we use all sorts of different things to get together. Just this week, we're happening to get together in person here in the Wairarapa, which is great.
Thank you again, Duncan. I think we're gonna probably end the questions there, because I know that Duncan is actually late for dinner. So we're not going to hold him up any longer. And again, thanks so much for a really excellent presentation. Thank you to the audience for joining us today. As I said, this is a celebration of the first human in space. Also for Space Base, if you are interested and don't know much about us, just go to our website as well. It's spacebase.co. We also do a monthly podcast as well. And this month, in collaboration with Becca, we normally do a webinar series as well. So on April 27 at noon, the next the webinar is actually with Xeno Astronautics and Extraterrestrial Power, so two space startup companies here in New Zealand. And then also for Tech Week next month, just to flag, we're also doing a Back to the Moon, basically panel discussion on the 18th of May with a number of lunar companies.
Hopefully right after a Electron launch for sending Capstone towards the moon.
Which is going to be the first basically Artemis mission.
Launching from New Zealand.
Launching from New Zealand. So great. Thank you very much, and have a great evening, everybody.